In this video, we're going to discuss some properties of the dot product. So recall, if we have vectors A dot B, then there are two ways we can compute this. We can use components, or if we're given the vector's magnitudes and direction, then we multiply the two magnitudes and then times cosine of theta, where theta, if this was A and B, theta is the angle between our two vectors when we place them tail to tail. All right, so what are our properties of the dot product? The first is that it's symmetric, which means that taking A dot B is the same thing as B dot A. And hopefully you can sort of convince yourself of that by looking at the formulas, which are symmetric in A and B. The next one is that if we are multiplying some scalar times A dot B, that's the same thing as if we were to multiply the scalar times A first and then dot it with B. But notice the scalar doesn't also attach to the B. We don't have two of them here. That would be C squared. So just we could associate it with one of them, or indeed we could have associated them, the scalar, with the B instead. So we could multiply B by the scalar and then take the dot product. And those would be the same thing. We also have A dot, if we were taking B plus C here, oh, sorry, plus, then we could distribute the A in. And this is the same thing as A dot B plus A dot C. Okay, so those are sort of the main algebraic properties of the dot product, and hopefully these all should feel very familiar to you based on your experience with sort of usual mathematics that you've been doing up until this point. Hopefully these all feel quite intuitive. All right, what if we take A dot A? So if we take the dot product of a vector with itself, this is the same thing as the magnitude of vector A squared. And how do we know that? Well, that's because using our formula, this is A times cosine of the angle between A and A. But A is obviously in the same direction as itself, right? If this was A and then we draw another A, it's the same direction. So the angle between them is 0. This is cosine of 0. And if you recall, cosine of 0 is 1. So indeed, this is equal to A squared. So a vector dotted with itself, you just get A squared. And in fact, whenever you have two vectors that are maybe different vectors that are parallel to each other, then you get the magnitude of A times the magnitude of B. So this is for parallel vectors. So it could be like this is A, then maybe B is longer or shorter, but it's in the same direction. All right, and that's for the exact same reason that cosine of 0, right, the angle between these would be 0, and cosine of 0 is 1. Then finally, if we have A dot B where the vectors are perpendicular to each other, then we get 0. This is for perpendicular vectors. What do I mean by perpendicular? I mean they are at a right angle to each other. So if this was A and this one was B, and there's a right angle between them. And why is that? That's because cosine of 90 degrees is 0. So the dot product vanishes when two vectors are perpendicular. I'll also add some notation I often use for parallel and perpendicular. This means A is parallel to B, and this means A is perpendicular to B. That's fairly common notation that some of you might have seen before. All right, so these are the basic properties of the dot product.